Hello everyone, welcome to my channel Let's Play with Code. This is our third lecture in the series of OpenCV. In this lecture, we are going to see some more methods of OpenCV. The method that we are going to discuss today is cv2.cvtColor. cvtColor is a method of OpenCV used to change the color space of the image. The first thing that we do while working with OpenCV is importing the module. This I import numpy as mp import cv2. So cv2 dot imread will take the image from our wallpaper. Here's the image of beautiful car. We'll paste it over here. This will give us an image. Now we will visualize it using cv2.imso original img cv2 dot wait key cv2 dot destroy all window, and now we'll run this code. So, mistake is in that we have created double s. Okay, here is the image. It is big in size. Okay, let me tell you one more thing about this. There will be an s here. There will be an s. So as you see, we have imported an image which is big in size. I have told you one method to resize the image, that is cv2.resize, and here we can pass image name and the value that you want your image to be 600, 500. 600 will be the size of width from here to here, x-axis, and the 500 will be the height, and it will give you a new image img1, and we will visualize this new image as img1, as you can see. But let me tell you one more. There is one more way of resizing your image that is present in imread method as well. So here you can use flags like cv2.imread, then you can press tab. Okay, I'm pressing here tab. Then after pressing tab, you can see these are all flags that imread provides, using which you can read the image into different formats. Like here we use imread reduce color 2 and imread reduce color 4. This means the image will be in colored form and it will be reduced by 4. The scale will be reduced by 4. So here we'll use cv2 imread reduce color 4, and you see it gives you a reduced image. Sorry, no, this is not the one. We have to use img as well. See, here we are not using resize. See, I have already commented the resize line. There are some more flags here, like if we use press tab, then we use reduce grayscale 4. Now it will convert the image into grayscale and then reduce the image by 4 scale. So here it is. Okay, so these are the flags of OpenCV that it provides. We are going to see a method called cv2.cvtColor. Now the method cv2.cvtColor OpenCV is used to change the color space of the image. Okay, as we know that image is read using imread, the color format is always in BGR. But if we want to change the color space into other color spaces, then we use this method known as cvtColor. In cvtColor, we only need to give two parameters. One, the image of which we want to change the color, and second is the flag. The flag that cvtColor provides. So the flags are cv2 dot capital COLOR. Just you type cv2.color, press tab, and you will see all the colors. The one thing that you need to keep in mind is you always need to use correct color format. We know that IMRead converts the color into BGR. So first we need to use convert BGR, then to, for example, I want in RGB. So let RGB. You should always use a correct color changing flag. If my image is in RGB and I'm using BGR to RGB, then it will show error that the image is not BGR. So now I'll save this image into IMG1. This is IMG1. You see here, when we first read the image using IRead, the color format is in BGR. The three channels are representing the color intensity of blue, second channel is representing the color intensity of green, and the third channel is representing the color intensity of R. But as soon as we change color format to RGB, the numbers are same. The numbers are not changed. The number is still there only. But now it thinks that the first channel is representing to red channel, the second channel is representing to green channel, and the third channel is representing to blue channel. And this is what it performs. Changing the color space by making it look like that the channels have been changed. You can also perform this particular operation manually. Let's try doing this operation manually. The first thing that we need to do is cv2.split. What the method does is it splits the image into three individual channels. So we will save these three channels into B, G, R. Okay. Now if you visualize this B, you'll see channel of blue intensity color. Okay, it has been split into blue intensity. This will be the intensity of green, and this will be the intensity of R. Okay, in this sequence it is representing the BGR format, but to represent the RGB format we simply need to change position of the channel. So to do so, we have a method in cv2 known as cv2.merge, merge, and here we need to pass the arrays on which format you want. I want it to be in RGB, and now it becomes an RGB image. Now it becomes an RGB image, and if you visualize this RGB image, cv2.imshow RGB img RGB img. Here it is. What is the mistake that we have? We have not used the original name. Okay, we always need to use original name. So now you see, let me explain you. Here what are we doing here? Okay, the first thing that we are doing is we are reading the image using IMRead. Whenever IMRead reads any image from your folder, converts the image into a numpy array, and the format of that image is in BGR color space. OpenCV only uses the BGR format, and it only understands the BGR format. Okay, but we can convert the images into other formats accordingly, but while displaying and while reading, it only understands BGR format. The IMG is now in the BGR format. So the method to convert BGR into RGB that cv2 provides is cvtColor. In this method, you just simply need to give the image name and the color flag cv.split img. This method is used to split the channel individually, returns a tuple of channels. So here we are doing tuple unpacking. B variable is taking the blue channel, the green variable is taking the green channel, and the R variable is taking the R channel. Now we need to combine it back. So here cv2.merge is used to do that particular thing, and RGB, and we have made it in a RGB format. Now if we want, okay, there's one more thing that we can do. Let's play with code. Okay, we are playing with code. So now if we want to see what the blue color is giving, we can only visualize the blue color. To visualize the blue color, we will make the green and red, we make it 0. So to do so, in the merge we can write, let's write here. Okay, np dot once zeros like mp dot zeros like b. Mp dot zeros like is a method of numpy which will create a array filled with completely zeros, but the shape and the size of that array will be equivalent to b. Okay, will be equivalent to b. So we'll save it here. Actually, yes, we can save, or we don't want to save, then we let's don't save it. Why to directly we will use in our merge. Okay, so the first thing that we want to show is the b. We want to only visualize the b color. So here b, here np dot zeros, and again np dot zeros. Okay, these are the three colors, and this becomes blue image. This becomes only the blue image, original image, the blue image. We'll run it, and here you see this is the color intensity that the blue color is giving in this image. This is not the blue intensity that is created by us randomly. No, this is the color intensity that is present in this particular image, in this original image. These are the blue colors that is present in this image. Now let's visualize the other colors as well. So in order to visualize the other color, we just need to say copy this code. We can copy this code and let's say in green image. We'll save it and we'll write here G. Okay, we can keep this zeros like as b only, but just to be safe, who knows, maybe the color shape are not accurate, so we're using their name as well, because you know the names should be, the sizes should be same. Here we have r, sorry, here we are using r and below r, zeros like r, and here r. Okay, and then we visualize this blue image, green image, red image. This is b image, this is g image, this is r image, blue, green, red. Run it, and here it is. Okay, some kind of mistaken. Okay, this is a very beautiful mistake that we have done. This is necessary as well, and here you will get why we are getting only blue channels. As I told you, OpenCV reads the image in the format of B, G, and R. This means OpenCV always thinks that the value that are present in the first channel are blue colors intensity, and the values that are present in the middle channel are the green color intensity, and the value present in the last channel are the red color intensity. Okay, so even if we simply bring this color space and put it here, it will not think that this is green channel. It will always think that the first channel is for blue channel only. Whatever the value changes, I will change the intensity of the color, but this color will always represent blue color only. So here what we have done, we have used all the colors in the first place. That is why it is saying that this is also representing the blue, this is also representing the blue, and this is also representing the blue, and all the second and third colors are 0, 0, which means 0, 0 is black, and blue and all others are black will give you blue only. So to actually overcome this, we need to use the correct position of all these values. So like blue is on the correct position, green will come at the center, here will be green, and red will come at the last position. Red will come here. Now you see, now you will get here, you see, this is the red channel, this is the green channel, and this is the blue channel. Combining all these three channels, combining all these three color intensities, we get this color. And to change the color space, we need to swap it. After swapping, we merge it, cv2.merge, merg merge, and we put here R, G, B, and RGB, RGB, and this is the original image, and this is the RGB image. Other than RGB, the color space that OpenCV has is one more, is HSV. Here H stands for hue. hue, S stands for saturation, and V stands for value. In HSV, hue ranges from 0 to 180, and every color is between these two values only. It means here 0 to 20 will represent the color of red, then it will move to something 25 to 35 green and all that. There is a website also where you can check the values of HSV. Let me tell you, here it is, HSV color space C. It is showing 355, but in OpenCV the value of hue is from 0 to 180, and between these two values only you will get all the colors that are present in this bar. And these two values in OpenCV goes from 0 to 255. This is for the intensity of the color, and this is for how bright color you want. So now we'll go back over here. We'll see. So now we converted our image into HSV and we are reading it. BGR to IMG1. Here we'll make it IMG1. Okay. Let's do one thing for you guys. You understand better. Let's copy this code. We'll copy this code and we'll paste it here, and we'll remove all the things that we have done before. I hope you understood what we have done. We have used the methods like merge and split to convert our color space. Now we are using the methods of HSB. Now we are displaying the IMG1. Here you see. So this is what when we convert BGR to HSB happen. Because as I told you, in BGR every channel is representing two color, but in HSV only one channel is representing the color format and the other two are representing how bright and how intense you want your color to be. So this is what BGR to HSB looks when you convert it. Let's keep it BGR to, we can also do BGR to gray. So if you make it gray, see it gives you a grayscale image. After converting grayscale, we can also convert it back to BGR cv2.cvtColor IMG1, because IMG1 is now grayscale. So IMG1 cv2.c color GRAY gray to BGR, and we'll make it IMG2. Here it will be IMG2. Run it. See, one more important thing to note here is that when we convert the colorful image into grayscale, it gets converted correctly. But when we convert a grayscale image into colorful image, it is not getting converted. Why? Because grayscale image loses the information of the color. Now grayscale image has only one channel in it. Okay, so this is all we need to know about how we need to convert the colors of the image. Thank you for watching, and I will see you on the next lecture.